Here's problem 1334. The planet Venus requires 225 days to orbit the Sun, which has a mass of 1.99 times 10 to the 30 kilograms, in an almost circular trajectory. Calculate the radius of the orbit and the orbital speed of Venus as it circles the Sun. Well, this period of time is 225 days, and we know that there is 24 hours in a day, and that there is 3,600 seconds in an hour. So the hours cancel out, and the days cancel out, and we can get the number of seconds in Venus's orbital period, and that is 1.944 times 10 to the 7 seconds. Sounds good. Well, this period relates to the radius of the orbit by Kepler's third law. Period squared is equal to 4 pi squared over g times the mass of the central body, in this case the Sun, times the radius of the orbit cubed, Kepler's third law. Solve this for the radius of the orbit, multiply both sides by gm, and take the cube root. So the radius of the orbit is going to equal g times the mass of the Sun times the period squared divided by 4 pi squared, all this cube root, or to the 1/3 power. So this radius is equal to g 6.67 times 10 to the minus 11 times the mass of the Sun, 1.99 times 10 to the 30, times the period of Venus's orbit, 1.944 times 10 to the 7, that period squared, over 4 pi squared, all this cube root, or could say to the 1/3 power, and that gives us a radius of 1.083 times 10 to the 11 meters. That is the radius of Venus's orbit, just about 2/3 the radius of Earth's orbit. The velocity will be equal to the circumference of this orbit divided by the time it takes to complete this orbit, which is the period t. So this is going to be 2 pi times this radius, 1.083 times 10 to the 11, divided by the period of time to complete it, 1.944 times 10 to the 7 seconds. And that gives us a speed for Venus going around 35,007 meters per second. So that's how fast Venus is going. 35 kilometers per second is the speed of Venus in its orbit around the Sun.